Team, welcome to ISTQB certification foundational level live training, that is CTFL live training, day 2. Previously, we have done two detailed orientation sessions in which I have explained the exam structure, procedure, your local website from where you can look the informations and everything. Any questions related to that, please watch orientation session 1 and session 2. And today we are actually getting into the main topics that we are going to learn out of the 6 chapters that we need to go through as part of this course. So the agenda for today is that we will be talking through chapter 1 in detail. In chapter 1, the first one that we will try to understand is why is testing necessary? What is the purpose of the testing? Uh, Basically, how it got introduced and what is the necessary of testing. So before that, we'll look at some of the classic problems, how they got introduced, and why the testing has become necessary. Then we'll understand what is testing itself is all about. Then we'll talk about seven important testing principles. Hope rest of you can hear me, right? Resby, I think you should sign out and sign in. So we'll talk about 7 important testing principles. Then we'll talk about fundamental test process. What is the process that we need to typically follow? The psychology of testing. The last one is code of ethics. There are certain ethics that the testers needs to follow during the course of action of performing the testing in the project. Followed by, after understanding these 6 chapters or whatever I complete today, for example 3 or 4 topics, I'll conduct you a small mock test which will help us basically to go through certain sample questions, how you can answer them. So that's the overall idea for today. So any questions on the agenda? Fine, let's get started. So from now onwards, all the things we're going to deal is in a Word document. So if you remember in the last session, I was trying to show you what kind of books that are suggested from the ISTQB. So going through all those 5 or 6 books may not be possible for everyone for various reasons. It could be the content that is available in that, or it could be the cost of the books or anything. So this material is prepared by collecting the important informations from all those books. So if you go through this is much more than enough. And if you still have some time, you can go through one of those or two prescribed books in the ISTQB website. Okay. So to start with, we need to understand why is testing necessary. So any software, basically, it could be an application software or it could be a product that is general use for a general purpose, or it could be an application which is specifically designed for one type of customer. And nowadays we use a lot of mobile applications in our day-to-day real-time transactions, uh, applications that are going to be deployed on tablets, smart PCs, etc. Whatever the applications that are there, so why we need to test them before even it goes into the real market or service? So why do we need to test? So there are these are some of the classic examples that resulted in failures around 15 years back. If you see 15-20 years back, that there was not much of testing, actually speaking. So developers used to write the code and they themselves used to do little bit of testing, and then they used to release. And what happened there was it resulted in lots of maintenance cost. All those applications resulted in a lot of maintenance cost means after the application went live, they started giving all the problems. And those issues are very complex issues. Like some of these examples that we can see here is that the first launch of the European aerospace agency, the Ariane 5 rocket got basically crashed within the 37.5 seconds as soon as it got launched. This has happened in 1996, and the reason for this was a functional defect. So there was a functional error in the software that is being used, right? And you might have even remembered long back, not very long back, like maybe 7 8 years back. So Toyota has been recalled all those cars wherein there was a software defect that is being used in the gear system. So these are some of the examples where it got to the service, customers are using it, and then they are facing a problem. So now they are calling back and fixing that software and giving back is a big maintenance cost, right? Similarly, the other one is like, there is something related to exposing sensitive data by the UK government online filing of the tax returns. So where one of the customers can see the uh, you know, previous customers' information. We could see that the amount of a previous user earned. That is a exposing of sensitive data, which is a big risk from the application point of view. Similarly, in there is another thing related to performance issue. It is pretty common. So whenever there is a online any of the e-commerce application that you see, and if it is not so tested properly, and if you are opening it for the customers without doing a proper performance testing, and for example, if you open certain offers or during the festival season, or during certain timelines, if it is not properly gone through a load and performance testing, it may result in collapsing the entire software or that particular server. So similar thing happened in November 2005 for UK's top 10 when they announced the top 10 wanted criminals. So everybody went and checked the website, and it took offline within a short time of people started loading it. So this is the reason. The reason was a performance issue. And most of the banking, financial, insurance related applications needs to have a proper security testing as such. The reason, because that's where you actually deal with your credit card, debit card, personal information, and things like that. So those things should be very well properly securely tested. One of the things was this online book retailer, when it was went live, people started giving some negative number into it. And the reason for that was a security breach in the application. So these are just the classic examples to understand why the testing is important. But otherwise, 15 years back, frankly speaking, there was not much of testing, and people realized all these problems. What was the results of all these things? If the maintenance cost was very high, so that results in loss of money, and even for the time for the things to fix it. For example, if the defect is found during the course of the project development, the time to fix and the cost to fix is very less compared to once it is gone to the customer. So bringing it back, making the system down for the customer for some time, fixing it, then again giving it back is a huge time taking process. Not only money and time is lost, and the business reputation is also lost. So there's no guarantee that the customers will be using such information or such business applications going forward. So these are all still okay, all these related to either the business reputation or money or time. But thinking of healthcare related applications, healthcare related domain applications, that will have much more risk that it can cause the life of a person. If any software that is being used in diagnosing particular disease of a person, and if that software is giving you wrong results, for example, and the doctor is doing the medication because of the wrong results, then it actually causes the life of a person. So all these are some of the applications, just are examples, just to put you and understand why the testing is important. And that's being realized around 15 20 years back, and people started slowly involving into the testing at that time. And now we are in a stage where for every single project, customers or clients very much focus on asking, who is my testing team, and what are the different testing that they are doing it, what is the test plan that they are preparing, what is the strategy that they are going to follow, and who are my testers, have they qualified testers, have they gone through any certifications, or have they gone through any process. So clients are asking these kind of questions. Can I interview them? So that's some of the reasons why when you go for a job for a test engineer, after the company conducts certain rounds of interview, they may put through 1 or 2 rounds of client interview also, because clients are very much focused on the testing, because if the testing is good, they know their software will be good, their application software will be of quality. So we have gone to that level from the beginning, where there was no testing at all in 15 years back. Now we are doing so much of specialized testings in terms of functional testing, non-functional testing, like load performance, security, so much of different areas that we are actually covering up now. So that is the primary reason how the testing is started all over. Now, what could be the reasons that these problems will occur? So we just said there are some problems happen, and because of that, there is a results in loss of money, time, business reputation, and uh, and that's why we have making testing is mandatory. But before even go into understanding testing more in detail, let's quickly look at what are the some of the reasons why these problems will occur. First of all, these problems will occur for simple reasons, because entire software development life cycle is done by humans, right? And humans can do mistakes. They can do mistakes at any stage. Like, typical software project life cycle goes like, you have requirements followed by design, followed by coding or building of the software. Probably I'll just quickly put them up. So typically you have phases like requirements of the life cycle, then you have design, coding or build phase. Forget about testing for a minute. Coding or build phase, then implementation, or you can call it as deployment. These are the different important phases of it, and the mistakes can happen at any phase of this. Primarily, let's assume the main phase is a coding phase, where the actual requirements are converted into software programs. And if the developers are human beings who are actually writing the code, and they can do certain mistakes while writing the code, that can lead to these problems. Or it could be that people who design the system itself, they are not very effective, or they are not very efficient, and mistake could happen here. Or the project managers, program managers, or nowadays we call it as scrum masters, who actually captures the requirements from the product owners and the customers, they are not understood the requirements properly, and they are capturing it incorrectly. So even that could be the reason that why softwares will fail. So we are just trying to understand the reasons for it. It could be errors in the specification, it could be in the design, or it could be in the implementation of the software and system. Implementation is basically the coding and building of the software. So those could be some of the reasons why software fails. Another reason could be is that errors in the use of the system. If the end users are not trained properly, for example, you might have seen all these kind of problems when the banking sector has been they became automatic. Previously it was all manual records and everything, all the transactions were maintained manually. And when they started using these softwares during the banks, you might have seen such situations when you enter into the bank and the bank official is trying to struggle how to use it. Even though they have got a training, probably not everybody is become professional immediately, so they had faced a lot of problems in using the software. And same case with airline ticketing, train ticketing. When you go into these automatic softwares, I'm talking about a scenario way back when the softwares got introduced into all these areas. So errors in use of the system, how the user will use the software. If he is not going to use it properly the way it is expected to be, even that can create a problem. Of course, you might have a question. Fine, if some of the user is a dumb user, it does not have any idea about the system, and if he's doing some mistake, why can't the software be so smart that it should give a proper errors or message? We are talking about an ideal situation where the software to reach to that level, yes, it is expected at that level. That can happen only if the system is being tested to that level. So you will understand very soon that much exhaustive testing may not be possible in every software. So we are talking about a scenario where no issues at all. So that may not be the real situation. It could be that the environmental condition. So the software has developed properly, but the platform on which you're going to run. For example, this software is being built for a Windows server, and the Windows server that you are using is not the intended version or expected version or with the hardware capacity and things like that. So the platform is not comfortable for running that particular software. You're probably running it little bit of lower version of it or anything. So those environmental conditions also will create a problem, right? And it could be that some people will try to damage your system if it is internet facing application and you are a famous application in the market. So there might be some intentional damages might happen to your server, and that could result in bringing the system down, for example. All of a sudden you realize your software is not working or it becomes slow. It is not because the developers have not developed it properly. It has been developed properly, but there is some hacking happening for your software, and that could be the reason that why your system is going slow or going down frequently. So the potential consequences of these things is that earlier errors, intentional damage, and then defects in the system, which can cause the failures for your software. So very soon, or the next thing, we will try to understand what are these terminologies like errors, defect, failures, and things like that. So any questions so far? All that we have understood so far is why a testing is necessary for a software, and what are the reasons why softwares generally fail. Okay, so any questions so far? I'll just take about a break of 1 minute. If you have any questions, I'll pause for a minute and then we'll move forward. Okay, so and these are some of the good things to understand and very important from the examination point of view also. So typically we have been called different terminologies for understanding those problems. Like sometimes we said failure, sometimes we said defect. Environmental conditions. Okay, so Sonal is asking, can you please explain again environmental conditions? Environmental conditions is nothing but, suppose you have developed a system. Let's say it's going to be a client server application, and you need to host it this particular server component on XYZ servers. You can run it on Windows server, Unix server, Linux server with these hardware requirements. So there is a uh, clear information about on which platform you can run these softwares and all. Suppose if you are running it little bit lower version of that, or maybe the memory is not sufficient to run that software, or the hardware itself is not 100% compliance to the requirements of that particular software, then you will get all those problems. So I'm talking about platform point of view. So that is where you do this compatibility testing, cross platform testing, and all that, to ensure that our software is running it on multiple platforms. For example, you downloaded one app, and that app is supposed to run on two different operating systems on your mobile. It could be, let's say, Android and Windows, and your mobile is meeting not 100% requirements of that software. Let's say it's meeting 90-95% of the requirements. So you downloaded the software, it's downloaded, but while running the software you're facing some problems because the environment is not 100% compliant. So I'm talking from that perspective. Platform. Is that fine? Okay. Now let's try to understand what is a bug or a defect. They are actually synonyms as far as the ISTQB terminology is concerned. Okay, they are synonyms. You can call them as bug, or you can call them as defect, or you can even call them as fault. Then we'll try to understand error, what is a failure, mistake, what is quality is all about, risk, and then what is software testing, and finally we'll try to even understand exhaustive testing. Okay, let's go one by one. For example, what is error? I don't think I need to define. It's a general English terminology. So if someone makes an error, okay, if someone makes an error, or you can use a simple terminology like a mistake in using the software, This may lead directly to a problem. For example, if the user is not using the system properly, if he or she is doing a mistake, and that will lead directly to the problem in the software, right? Because the software does not work the way it is expected. Okay, what is a definition of error or mistake? Is a human action that produces an incorrect result. So read out the definition again. It is directly from ISTQB glossary. So in the ISTQB website, they have given a PDF file which consists of a lot of glossary or definitions like this, and some of them will directly appear in your exam. What is the right synonym for error, and then they'll give you four or three or four multiple choice answers from which you have to choose the correct one. Okay, so we can define error or mistake as per ISTQB glossary is that any human action, there's a human being who is using the software and he is doing some action which is resulting in an incorrect result, which produces an incorrect result. So that is what is called a mistake. Basically, he's not doing the right thing. He's doing some action which is giving an incorrect result. So that you can call it as an error or mistake. So by doing that, what happens is that, for example, if you can take it from a developer perspective. So developer has to write some code properly so that the software is going to work properly. But whatever the reason, it could be problems with, or he could be an inefficient developer, or he is writing the code in a situation where he is not in a comfortable mind, or whatever the reasons, he has done some mistake. He's a human being, he can do mistakes, and that mistake has resulted in an incorrect code. Now when that code or software goes for the users will have a issue in using the software, or they will have some unexpected behavior. So that is what is called a defect. Okay, so what is mean, I'll come back to risk a little bit later, but what is a defect is a flaw in a component or a system where it failed to perform the required function. So for example, he has written some tax calculation logic or something, and when the actual person is using the tax calculation logic, the numbers are incorrect. When he uses manually or when he uses other software, the numbers what is expected out of the calculation system, they are not coming properly. So why this is happening? Because somebody did a mistake during the coding. This is what is happening. So a error, if you can see this particular flow chart which I have given in the bottom, an error, somebody did a mistake in the during the coding or during the requirement or during the design, can cause a defect in the software. So defect is nothing but a flaw in a component or a system which is basically make it to perform, basically it will make to fail to perform in the required way. Examples: an incorrect statement or data definition, or a defect encountered during the execution. These are some of the things which will make the system to fail, right? Okay, what is a failure? It is basically deviation of the component or system from its expected delivery. So the final result, right, we're talking about from the software that end user is using, and he is not getting the tax calculation numbers correctly. That is the failure for the user. Because the system is not behaving properly, the end user is not getting the final result correctly. So that is a failure of the software. I'll redefine them again. Error is something where a human does a mistake during the requirements phase or design phase or coding phase. This is what is called error. Because of that, some defect will happen in the system. And when the defect will be caught, if somebody tests it before it goes to live, if some test engineer or some developer or somebody tests that piece of function or piece of logic, there is a chance it might come out. There is a chance it might caught. But if the testing is insufficient, if the testing itself is not proper, even they also miss out that particular defect, and finally it will go into the live environment. And what will happen in the live environment? Live environment, the system will become fail if somebody using that feature. The reason because it is not working as expected for that particular calculation logic. So that is called fail. So when the end users are using, we call it as a failure of the system, because how they report it, they don't report that I found. Of course they do if they are, your users are, some of the technical people, they may say, hey, I found a defect. But think from a general perspective, if the end user is not a technical person, he will simply come back and say, hey, I got a failure in the system, this logic is not working. That is how he will come back. And when you analyze that failure, when you test certain features and all, then you may find a defect. And if you analyze the root cause why this defect is found, it could be the reason because somebody did a mistake during the coding or design or the requirement. So that is a flow. Somebody does a mistake, and that will result in a defect, which will result in the failure of the system. So is this flow clear now? What is mean by an error, what is mean by defect, and what is mean by failure? Again, I would like to pause for a minute because these are important definitions. You should not confuse among these three. Error, a human does a mistake during the requirement or design or a coding, and that will result in a defect. If somebody tests that feature, you might find a defect, otherwise you might not find a defect. And then a failure is something where the system is not behaving in expected way, where the users will notify that the system is failing. It's basically deviating from expected delivery. Any questions on these three definitions, error or mistake, defect and failure? They all are interrelated, yes, but the flow is something that you need to be very clear. Error results in defect, and defect results in the failure of the system. That is what the flow. Can you all see what I have highlighted here? Like, so this is what I want you to remember. So there is an error, first somebody does it, that will result in the defect, and that will result in the failure. That also works out, Sonal. You can raise the hand also, but I'm more habituated for looking at the text basically. So it will be helpful if you can raise the text itself, or if you can chart, put it in the chat window. Okay. So if there are no more questions on, okay, in what phase of these occurs also differ? It's very clear. Error can happen during the requirements when your project manager is writing the requirements, or if the project manager is very perfect, he captured all the requirements perfectly, all right. The next level, when the project goes to design, when they are designing the high level and low level design of the system, and if they do mistakes there, that is also will result in a defect. Or if the designers are perfect, they have done their job 100% perfect, now it is gone to coding, but during the coding developers have done some mistake, those are all errors. So error can happen either the requirement or the design or during the coding. And defect, we call it when somebody is testing those features, and if the things are not working, we call it as a defect. When the project gone live, and if the users are using the system, if the things are not working, you can call it as failure of the system. Yes, on which phase they occur is different. Okay, if you understand these three terminologies, there are two more terminologies you need to understand. One is risk and one is audit. Okay, what exactly a risk? A factor that could result in future negative consequences. Remember this definition again. You remember, like certain topics you have to remember. The Again, you can go through my orientation sessions. There are some K1 type of questions. What are those K1 cognitive level type of questions? where you need to remember certain things as it is. Okay. For example, this is one of the definition. The definition of a risk is that a factor that could result in future negative consequences, right? For example, what if the tax calculation logic is not working properly? What could be the risk? The risk is that we may lose the potential customer base because there are a lot of issues that they are actually facing, or there are a lot of failures in their calculation logic. So the risk is that we will end up losing the business, right? That is the future negative consequence that could occur, usually expressed as an impact or likelihood. So generally we'll say, we normally calculate what is the percentage of risk, or whether it is going to be a high risk or a medium risk or a low risk. We'll even categorize them. But the actual definition of a risk is that a factor that could result in future negative consequences is what is called risk. For example, if like we have seen, one of the security risk we are talking about. If you are not taking care of all security principles that are required, or security measures that are required for our system, and we are rolling it down for the life, the risk is that there is a threat for customer information. There is a threat for banking information like credit card, debit card information. So that is a risk that could happen if somebody hacks our system. So a factor that could result in future negative consequences. The other one is called audit. So what is an audit? The meaning of the audit is like, fine. You are saying somebody has to ensure that what we are doing is we are doing it correctly, right from requirements to the implementation of the software, so that when it goes live, there will not be failures in the software. Customers will not face any problems, or they won't face any failures. The process of checking this, right from your requirements to the implementation phase, the process of checking at every stage whether the things are going right, in the right direction, that process is called audit, right? So basically executing the tests help us move towards improving the quality product. So we take some kind of precautionary steps and some kind of steps during the phase of the life cycle: requirement, design, coding, testing, whatever the phase. And then we prepare a lot of checklist to ensure that we have done the things correctly. Why are you doing all this? Because you wanted to finally result in a quality software which will not have, I would not say which will not have any failures. I again, even though I have about 12, 13 years of experience, I have been closed a lot of system into live, saying I'm signing off these systems with maximum quality or 100% of quality. I still never believe a concept of zero defects. Nobody can sign off saying this particular software I have tested and it has zero defects. Nobody can say that, because we don't know. There might be some still lying defects somewhere in the corner of the software which I have not covered, or which I cannot cover because exhaustive testing is not possible. But we are trying to take a precaution or steps to ensure the maximum quality of the software, right? So the process of checking whether things are taken in the right direction or not is called audit. So that's why a lot of companies, what they do, they follow these quality processes like ISO process, CMM process, Six Sigma process, to ensure they are doing the project in the right way, and that will result in a quality of the software. And whichever the company follows these principles, they will have frequent audits for their softwares. In fact, every month there will be an auditor assigned for every project, and that auditor will come and check so many things in the project, whether you're maintaining the proper requirements or not, whether you are maintaining the proper design or not, whether you're doing a proper code reviews, inspections, you're doing a proper testing or not. So why are we doing so much of process and then audit on top of that? Is to ensure the quality software. Okay, there are some questions or comments from Resvi. Verification of created test cases by test lead could be audit. It is, as you rightly said, it is a verification. See, again, there are two terminologies that we keep on using it. One is called verification, the other one is called validation. So let me explain these two. If you are reviewing any document, any documents like SRS or FS, right? SRS or FS, or if you are reviewing any design documents, right? Or if you are even reviewing a prototype where you cannot really test it, but you can basically you can just check whether the prototype is correct or not. So these are basically called verification. There is nothing for you to run the system or run the software and perform some validation on that. So that is why we call it as verification. But what exactly validation is that? If your software or program is ready, you install or you directly run the software or program, then you check certain functionalities, right? Certain features by inputting the data. So this is something called validation. Whether you input right data, incorrect data, like positive data, negative data, that is your positive testing and negative testing. But overall, running your software and checking certain features are working or not by inputting the data, that is called validation. So these two are different terminologies, verification and validation, right? So what I now coming back to your resume point, verification of created test cases by test lead could be audit. I would still call it as just test cases review, or I would still call it as a test cases verification. Not really a big term like audit for that. Audit is something, if somebody is coming and checking whether you are writing the test cases in the right format or not, whether you, for example, when you follow, let's say, a CMMI process or an ISO process, the auditor may come and check, hey, can you show me the test case format that you're writing? And then he may say, hey, you're not using the prescribed format by the organization. You're just writing it on your own. You need to follow this IEEE standard format, or you need to use ALM software, or you need to use Microsoft Test Manager software to write your test cases. So that is something, that's where he's just doing a check on a high level check on the format. And whether, because why is he insisting on the format? Because that format is taking care of all the required things. Okay, then is it could be any phase. Yeah, it could be in any phase. The audit, typically audit will happen for every phase of the life cycle. In fact, they do every month. They come back and check every project whether you're following the things correctly or not. Okay, so these are the 5 important definitions that we have understood. You can take it as bug or fault as a synonym for defect. This is as per ISTQB terminology. Defect, bug, or fault, they are all same. Okay, so any questions in these terminologies? Error, risk, defect, failure, and audit. Okay, so now you understood defect. Defect is something where somebody did a mistake previously, and that is resulted in a program not working or a feature not working. And if someone is validating that, there is a chance that he or she can caught that particular defect or bug or fault in that software, right? Now when they occur, I think I've kind of explained it textually, but this is a good representation of the diagram to understand when defects arise. Okay, so these are the different phases of the life cycle. Everybody can see this flow charts, right? First one, if you look at the first flow chart, the requirements are captured properly, design has been done properly, the high level design, low level design, whatever the design we do, the designers are perfect, they have done their job perfectly all right. The developers are also very experienced, and they have good knowledge on the system, so they have built it 100% right. If everybody is doing the things correctly, requirements captured correctly by the PM, perfectly all right, design is perfectly all right, coding is perfectly all right, then there may not be any defects in the system, and the software works as expected, the product works as expected, there won't be any failures for the customers or end users when they use it. This is the ideal world that everybody wanted to be in, every software wanted to be in this format, but frankly speaking it is not possible. As I just said, even if somebody says we have delivered a project without any defects, zero defects, I'm not going to believe it. Probably the testing team who has done that might have not done 100% of the exhaustive testing, which is not possible, and users have not used it 100% of it till now, that's why they have not got any bugs. So definitely there might be still some problems that may come in the future, or when somebody uses that particular feature with that particular data, it might come. So but we are talking about an ideal situation where everything is perfectly all right, then no issues. So that's why I've represented everything is kind of rectangle, that no issues, correct functional and non-functional attribute have been delivered. The second flow that we are talking about is requirements have been captured correctly, design has been done perfectly all right, but while writing the code, developers have done mistake. Okay, in one of the feature or one of the component, developers have done mistake, and what will happen? That will result in bugs. So product has bugs or defects or faults, you can call them, right? Do you think they are correctable defects or non-correctable defects? They are correctable defects because the moment a tester reports those defects, now developer will look at that and then identify what could be the reason for that, where the mistake has been happened, and then he will correct the code. Then things will come back to normal. So in the second flow, we are looking at a situation where developers doing the mistake. While reviewing requirements, how can entry level tester know the requirement can be tested or not? While reviewing the requirements, how can an entry level tester know if the requirement can be tested or not? So frankly speaking, how things will work out in real time is, when the requirements are given to you, based on those requirements, the testing team has to come up with a test plan or a test strategy. How they are going to test about it, only manual testing is enough, do we need to do any automation testing, how critical these requirements are, how much efforts will be required from the testing, all that planning is done by experienced people. So who will prepare test plan? Test plan will be prepared by a person who have at least 3 to 4 years of experience. And you're talking about somebody who has an entry level person, how he or she can do the things. So definitely there are highly chances that person will do mistakes. uh, that person may not caught all the bugs in the system because he is not experienced for the first of all, and he has not seen the different systems. So it is not going to match to the 100% expectations of the testing, because based on the requirements we have to come up with a plan or strategy, and that can be done by only somebody who has some experience in the system. So does it answer your question, Lakshmi? Like I'm saying, it may not be a proper testing. Even he is a very smart guy, but he may not think through all of them. Requirement need to be reviewed, not tested. Yes, requirements needs to be reviewed. Requirements, design documents, prototypes, as I just said, it's all review. Testing or validation starts when certain system is ready, when certain software is ready, which you have to install, and run the software, input through certain inputs, and feed some data, test it. That is what is called validation. So validation is actually a synonym for testing. Validation is equal to, you can call it as testing, but actually testers does both. If you are a tester, the testing team does both verification plus validation. You do both of them actually. During the requirements of the project, what you do is verification, right? So you do verification. During the execution of the project, testing of the project, what you do is validation. So you do both of them actually. But the synonym for testing is basically the validation. Okay. Now look at the third flow. The third flow is where requirements have been captured perfectly all right. Your PM is perfectly all right. So he understood the requirements from the business well, then documented them in nicely, ensuring their all scenarios have been covered, user scenarios have been covered. But the designer who is actually designing the system, he did a mistake, right? He may not understood the requirement, one of the requirement properly, and then he designed the system incorrectly. Now because of the design incorrect, now the developers also will do the mistake because they simply follow the design and write to the code. So design itself is incorrect, so your coding has become incorrect. Coding has become incorrect, obviously there will be bugs in the system. When the testers take the requirements as base and when they try to validate, for the testers to test what is the base requirements, SRS or FS is a base. Of course, they refer design, they refer other things, but prototype, but the primary thing is a requirement. So for example, if there is a smart tester who is focusing on the requirements and trying to test, he will find the problem, he'll find the defect in the system. And when we analyze the root cause why the defect is occurred, they analyze it is because of the design. And again, if you understand why the design has become failed, they understand, sorry, for example, if somebody is analyzing a defect, they analyzed and found the root cause is because of the coding is a problem. But why the coding went problem, they analyzed it that it's because of the design. So the primary root cause happened is at the design level, not in the coding level. So developers have done their job correctly as per the design, but the mistake is done by the designer who has designed. So this could be another scenario where designers are doing a mistake. The last one is the worst scenario where requirements itself gone wrong. Obviously design will go wrong, coding will go wrong, and the testing definitely will find out the defects which are not expected by the customer. Basically customer is expected the system to work in one way, but the overall system delivered is totally in a different way, right? So that is a fourth one. So the first one is the ideal world that everybody wants to be in, the software to be developed with the right requirements, right design, right coding, and then it go into the system live properly. But it can happen that developers do mistake, or it could happen that designers do mistake. It could happen that requirements can go wrong. So Sonal has a question: who does a design in big products, big application software companies? They maintain a separate role called designer or architects. They will design the system. But in smaller companies, one of the senior developer, for example, there are 4 developers and one of the developer has good experience like 8 years, 10 years, he himself will work as a designer. But in good product companies, good application software companies, there are some specific roles called designer roles or architect roles. They will be the one who will design the system. Is it clear? They will have knowledge on the technology, they will have knowledge on the domain, they will have knowledge on external systems, how they will you consume our software. Putting together all that knowledge, they will come up with a design. Okay, now that we understood where the problems can go wrong or where the defects can get introduced, right? When the defects can get introduced, let's try to look at cost of fixing those defects. Okay, cost of fixing those defects. For example, if A PM is writing the requirements. We are in the requirements phase of the life cycle. For example, we are here, requirements phase of the life cycle, and who does it? PM does it, right? PM writes SRS or FS. After that, he or she has to review also, review the SRS or FS, and then she will share it with the other teams, and other teams also will do the review. So whoever it could be self review or it could be the review by the team. During the review or during the verification process of SRS, they found a problem that one of the requirement is captured incorrectly. Now, what is the cost of fixing that? It is very less. It is just going back, uh, getting confirmation from the customer, double check from the customer that this is what you're expecting, right? And the customer says, yeah, yeah, that's what I'm expecting. Going back and fixing it in the document. So the cost will be very less, right? And that's why you can see the cost will be very minute. But think about a situation where SRS is completed, review completed, nobody found that problem, nobody found that discrepancy. Now the project is in the design. During the design, what will happen? Your high level design will be prepared, low level design will be prepared, then it will be review of the design, right? All these things will happen. Review of design documents. While reviewing of the design documents, either by the same designer who did it, or by the testing team, or by the development team, or by the customer, they found a discrepancy. They found a discrepancy saying, hey, in the requirement you are talking about feature one like this, but in the design you are designing it in a different way. So there is a discrepancy between the requirement and the design. Then the designer agrees, okay, there is a mistake that I have done. He will probably double check with the customer if there is anything that he needs on the clarity, but if he knows very clearly that he has done a mistake, he will go fix the design and publish it, the latest one. So what would be the cost of it? It's definitely a little bit high compared to if it would have been identified. For example, what I'm trying to say is that the problem is at the design phase, and fixing at the design phase, again, it will be very minute. But think about a situation where the problem was in the requirement, but it got found during the design. So then what will happen now? This designer, he will say, no, no, I have designed it correctly as per the requirements that I have got it. So if you are saying, customer says it is not correct, then he will go back and verify the requirements, and then we found, okay, there is a problem in the requirement itself. So now you will have to go back from the design phase to the requirements phase, review that entire SRS or FS. If required, talk to customer, get a client confirmation. First fix it in the requirement, then fix it in the design. So that will actually create a lot of cost. Right? Are you guys with me? Okay. That is about the second flow we talked about. Let's assume there was a problem in requirements phase, but it did not found during the requirements, it did not found during the design, but it found during the build phase. When developers are writing the code, they found the problem that things are not correct. They go back and check it in the design, and the design says, no, no, I have designed as per the requirement. They go back and check it in the requirements. That is where the problem happened. Then obviously the cost will be very high compared to founding the requirements phase and fixing it in the requirements phase. A problem occurred in the requirements phase, but now the problem occurred in the requirement phase but found in build phase, so the cost will be high. Same case with the testing. Nobody found during the requirements, nobody found during design, nobody found during build phase. Now it is gone to testing, and the testing team, when they are actually testing the system, they found the problem. And now what will happen? It will, there is a process. When the testing team finds it, they are not the responsible one to fix it, right? So what they'll do, they'll report in a defect tracking tool, then developer will look at it, then he will say, no, no, I have developed it as per the design. So if something is wrong, it's only in the design, it's not my fault. Then the designer will come into picture. No, I have designed it correctly as per the requirement. If something is wrong, it's only in the requirement. So they'll go back and re-verify requirements. Then they realize, oh, there is a mistake happened during the requirements itself. Then they'll fix it in requirements first, then design first, then coding first, coding next, and that's when the testing team confirms, yeah, it's working fine now. So that is a much more costly thing that we're talking about. Frankly speaking, up to this is still okay. See, if normally this is another example that I try to give, just between the dev team and testing team, right? If you consider between the dev team and testing team itself, suppose if some developer is writing a code, okay, he has written some code, and as part of his testing, it's called unit testing, basically we call it as unit testing. Part of his testing, he found a problem. How much it would cost for fixing? It's very less because it is still within his premise. Probably he will open that project or solution file, make the code modification, rebuild it, job is done. Hardly he might be spending another 1 hour extra or 2 hours of extra for finding the solution for that problem and fixing it problem. So what would be the cost? The cost would be, let's say, $1. I'm just taking an example. Let's say it's going to be $1. But think about a situation where the developer did not find it and it has been passed to testing team. Now the testing team is finding it. If the testing team is if the testing team is, while doing the testing, they found the same problem which developer could not find it, so then there is a process starts. So you will report that bug in a tool, and the developer will open the tool and try to understand the problem. Then he will try to repro it in the dev environment. Once he is able to repro, then he will fix it. After fixing it, he will do unit testing. After unit testing is done, he will prepare a build and give it to testing team, who will deploy it in testing environment by the external team or same team. They will do the regression testing. Then they say yes, it is working or not working. So the cost will become somewhere around $10 easily, because there is a process involved, tools involved, two different teams involved. They may be sitting together, they may be sitting in different locations, we don't know. So cost will easily become $10. I would say this is still okay from a project point of view, because rather than it found by the UAT team. So for example, think about a situation where testing team also did not find it. They have done their exhaustive testing, what possibly they can do it. They did not find a problem. Now it is gone to customers. Customers are doing it. It is not gone to live yet. Still it is not gone to live yet. Where does the UAT team does it? They will do it in a pre-beta, or it's called beta environment, or it's called pre-production environment. Okay, they will always do it in pre-production environment. It's not a production environment, it's a pre-production environment. For example, if they are doing the testing and they found a problem, same problem which dev team could not find, test team could not find. Obviously after that there will be a lot of questions to the testing team, why you could not find it. We are answerable. Testing team is highly responsible for that, right? Because we missed it. So you will put your answers together, comments together, and say blah, 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 these are the reasons and all that. Depending on the type of the problem, your job might be at risk or not risk. That's a different scenario. I don't want to scare you on that particular front, but if you take care of your responsibilities properly, then there is things may not work. Okay, UAT team found the issue. So when the UAT team found the issue, what they'll do, again they'll report in a defect tracking tool, and then first it will be looked by the testing team. And what testing team will do, they will try to repro it in the testing environment, whether it is being reproable or not. Okay, they are able to repro, then they put their comments in the tool. We are also able to repro this in the test environment, and these are the test data, blah blah blah. Then dev team will try to repro in dev environment. They also able to repro. Then they will fix the code, do the unit testing, give it to the testing team. Testing team will perform regression testing. This time you'll be more cautious because you already missed once, so you'll be doing more testing. Then you give it to UAT. So the cost can anywhere become $100. It could have been done with a simple $1 fix, but it has gone to $10. That was okay, but that is also missed out. Now it has gone to $100. I would say this is once in a while okay, not every time. Once, because exclusively we have the testing team job is for that to eliminate all that, but that's okay. Once in a while you missed out, it's a critical scenario that you could not think of. Now think about a situation where we are in the live environment. All our end users are using it. Customers, actual customers are using it. For example, it's a banking application and one of the transaction is failing, or it's a healthcare system, one of the report is incorrect. Think about those scenarios. When the system is failing in the live environment, and if all the customers are reporting the issue, then first what will do, their UAT team will come to know, or support team will come to know. Then they will try to repro that. Then they will notify the dev and test team. Then test team will try to repro that, and then they put their comments, and dev team will try to repro and provide the fix. After that, they will do unit testing, will do regression testing. Again, customers will do UAT testing. Then only it will go to live. Now this we cannot really imagine. It may go to $1,000, $10,000, $1 lakh. I don't know, depending on the issue that customers are facing. Sometimes it bring down the entire business. Sometimes it completely, the company might collapse based on the issue that is happening. Right? We have seen so many things. So this is the cost that's going to happen. So that is why people wanted to take a clear boundary here. Even if we find with the $10, even if we can incur $10 for fixing a bug, we are fine. Even if we can eliminate with $100, that is fine. Because rather than going live and getting into these kind of bigger problems. So you guys with me, that's why the testing team has become super important. Super important for anything from the customer. This is engineering team and this is customers team. From the customer's point of view, we are the first one and the primarily responsible one, right? So that is what I'm trying to put it over here. The cost will raise drastically as we move to the phases. If it is live use, this is what can happen. So any questions on this scenario, understanding the cost of the defects? Any questions on this? Team, I'll take a pause if you have any questions on the topics that we have covered. It is this examination point of view, it's little bit of theoretical, so I'll try to give as many examples as possible so that it will be interesting. But yeah, unless we make it as an interactive session, it will be little dry. So put as much questions as possible so that we can make it interactive. Project comes to UAT after it is being tested by the testing team. Correct. Perfectly all right. After testing team signs off, then only. So testing team, the test lead will sign off saying we have done all possible things and now it is ready for the UAT. Then only it will go to UAT. Can we take rest of the class tomorrow? Yeah, that's what I'm trying to do that. Okay. Do you have any other questions, team? Okay, fine. So what I will do, I'll pause it here. We'll continue the remaining top, but we have to do a lot of things. That's fine. I'll do the rest of the topics in the next session. Even the mock test also, what I will do, I will cover it in. I will put it in the next, because unless right now I have not covered so much that I can really put that test in front of you. So what I will do, that the mock test will help you in just to get a feel of how the ISTQB questions will be and all that. So after tomorrow's session, I will be opening the exam for you. What to expect in the next session? So we will try to understand this. How do we keep this software, under control? What is mean by exhaustive testing? We'll understand what is the testing and quality definitions. Then there are some. So if you go back to the agenda, right, what we started today, we just understood only two things today. What is why testing is necessary and what is testing. So there are four other topics that we are going to understand. 7 testing principles. I touched upon little bit on that process, but we have to understand psychology of testing, code of ethics. So 3 things we have to understand tomorrow: 7 testing principles, psychology of testing, code of ethics. Fine. So go with this for today. tomorrow we'll talk about the next session, whenever it is, we'll talk about the remaining topics. So if there are no more further questions, we'll wind up here. Thank you. Thanks, team.